data I study is measured with different types of thermometers and particle instruments. So we're measuring magnetic fields and temperature and density on satellites in space.
Wow, that's pretty awesome.
Nice. What's your favorite planet?
I think Earth is my favorite planet just because it's the only one I've been to. If I got a chance, I'd like to see Jupiter up close. That would be the next coolest one.
Did you ever want to go to space?
I would love to go to space. The trick is making sure I have something to do when I go there. So I don't want to just go and like, there's tourism now, so you can fly to space for 30 minutes if you're rich enough. But I'd want to go and stay for long enough to do some sort of science experiment.
What's it like being a NASA
Astronomer.
It's pretty fun. It's a job. So it's a lot like any other job. I come into work at 9, I work until 5, I'm on my computer all day, I go to meetings. The most exciting part is telling other people I work at NASA.
That's awesome.
How do you collect science data?
So we collect all our data in situ, which means in space, in the situation where we're measuring. So I use 4 satellites that are called MMS, and they measure all sorts of different things. They're orbiting Earth right now, measuring the magnetic field, the temperature, the electric field, lots of different quantities in space.
That's pretty cool.
What science questions are you studying?
So the big science questions I'm studying are how Earth's magnetic field reacts to changes in the sun's magnetic field. So the sun is a really dynamic magnet, and sometimes its north is at the top and sometimes its north is at the bottom. And as it changes, Earth's magnetic field sort of responds to it. So I study how that response happens and what's going on there.
What is your favorite part of being a scientist?
My favorite part of being a scientist is finding new things that nobody's ever found before, or like so I like to think of science as trying to put together a puzzle. I've got all of these different pieces, which are my measurements from space, and I don't know what picture they're going to make. So I'm trying to figure it out. And when I get to an end result where I have a cool picture, that's my favorite part. Nobody's seen that picture before.
Before I forget, where are you currently located right now?
I'm in Maryland right now. So just outside Washington, D.C.
Awesome.
Where's that?
She said just outside Washington, D.C., so on the East Coast.
Have you ever used like chemicals in your work?
Don't use chemicals in my work. I did take chemistry in high school and in college, so I got to use chemicals then. So if you want to use chemicals, take a chemistry class. But now most of what I do is on a computer, so I don't get to use chemicals.
Why did you choose to study space?
So I got into space in high school. I had a really great physics teacher called Miss King, and she lent me a book called Death from the Skies, and it's about all the different ways things in space can kill you. And that sounds really scary, but it was actually really fascinating. And the book took a lot of time to explain, like, yeah, these things can kill you, but it's so unlikely it's going to happen. And instead, they're actually just really cool phenomena that we could study.
Gosh, I love that. A book and a teacher inspiring you to be a scientist. That's pretty awesome.
How many years?
How many years to go to school?
I went to school for 23 years. From kindergarten to when I finally got my doctorate, I went to school for 23 years.
Amazing.
What is your favorite part about being an NASA?
Can you say that again?
What is your favorite part about being at NASA?
My favorite part of being at NASA is all the different people I get to meet who also work at NASA and do really interesting things. So sometimes we have astronauts come in and tell us about what they do in space, and I get to talk to other scientists who study different types of science. So scientists that study the oceans and study the way the continents move, scientists who study climate change, scientists who study planets outside our solar system. It's a really, really cool place to work because you get to talk to all these different people studying all these different things.
So you've met actual astronauts who have gone to space.
I've met a couple, yeah.
That's really cool.
Wow. Are you from Iowa?
I am. I grew up around Marshalltown.
That's where I live.
Okay. Lizzie,
What's your favorite dwarf planet?
What's my favorite what?
dwarf planet.
Earth planet. I think Pluto. We've got a soft spot for Pluto because it used to be a planet and then it got downgraded.
Is there any other Earth-like planets?
There are a ton of Earth-like planets. They're just very, 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 very far away, and we can't get to them. So we're just one star in one galaxy that has 8 planets around it. There are billions of stars in our galaxy. There are hundreds of millions of galaxies. So there's lots of other stars that will have Earth-like planets around them, and we found a whole bunch. But we just can't get to them right now. They're way too far away.
Has there been any life on any planets in our galaxy?
We don't know, and we're still trying to figure it out. So a lot of our rovers and missions to Mars have been searching for evidence of life that might have been there. And so far, we found evidence that there was liquid water, which is a really important thing. I'm sure you guys know you need water for life. But we don't know yet if there was ever life on other planets in our solar system.
We'll come back to you.
How far away is like too far away? Like in the other Earths, like Earth-like planets, how far away is?
So too far away is probably anything outside our own solar system. But the Earth-like planets are light years away, hundreds of light years. So a light year is the distance light can travel in a year. So if you don't know how fast light travels, the light from the sun takes about 8 minutes to get to Earth. And the sun is about 93 million miles away. So if you wanted to do all the math, you could figure out how far a light year is, but it's the distance from the Earth to the sun hundreds of thousands of times over.
So it sounds like math's pretty important for your work as well. Did you love math as a child?
I did. I actually started out as a math major at Simpson and was sure I wanted to be a mathematician, and then found physics was a really fun way to just apply math and do math for a reason to solve puzzles.
Think of it, Shaven.
So how many moons Saturn has? How many moons do you think Saturn will gain in the next year and a half?
How many moons do I think Saturn will gain? Like new moons? It's probably not going to get any new moons in the next year and a half. Catching moons is sort of a weird process of you'd have an asteroid or some big rock fall into the orbit of Saturn. But the trick is it has to fall at just the right speed. If it falls too slowly, it'll fall all the way down to Saturn and won't be a moon. And if it's falling too fast, it'll fly away and not get caught. So it has to be flying at just the right speed to get caught. So it could catch new moons sometime in the future, but probably not in the near future. It'll take a while.
Mm-hmm.
Has any spaceship ever made it to Neptune?
We've never landed a spaceship on Neptune, but we've sent spaceships past Neptune. So you might have heard of New Horizons. It flew past Pluto a few years ago. And to get to Pluto, it had to fly past Neptune. And Voyager were a couple of spaceships launched in the 80s, I think. 70s or 80s, and they are all the way outside of our solar system, but they did fly past Neptune.
Is Earth's moon basically just an asteroid?
That's one possibility for how it was captured. We think that there was a big asteroid that hit Earth or got caught by Earth, and that's the moon, or when it hit Earth, it blew off a chunk of the Earth, and that became the moon. There's a couple different theories on how the moon was captured and created.
Quick little Indianola question. So why did you choose Simpson when you were looking for colleges? And then did you have a favorite place in Indianola when you were here?
I chose Simpson because they had a really great math program, and I really liked the campus. It's a really pretty place to live, and the professors were really great. I had a couple really great professors at Simpson. My favorite place in town was probably Buxton Park. I'd sit out there and study and read all the time under the trees.
We love Buxton Park too, don't we?
Yeah. Is there more stars like the sun?
There are lots and lots of stars like the sun. The sun is actually a really average star. So most of the stars are pretty similar to the sun.
How long have you been working at NASA?
I have been working at NASA for about 1.5 years now. So it took me a long time to get through all the school before I could start working at NASA.
Do you believe in aliens?
I don't know if I believe in aliens. I'm excited to see evidence of aliens, but we just don't have it yet.
Have you ever seen a UFO?
I have never seen a UFO.
Have you ever seen cool gas clouds in space, something like that?
Yeah, so one of the fun things working at NASA is I get to go see other scientists talk about their work, and a lot of them are studying nebula and star formation regions in space. So we get to see really cool images. The part of NASA I work at actually runs the James Webb Space Telescope, which is the newest telescope looking deep into space and seeing all sorts of things like that, where stars are born and gas nebulas.
If you haven't asked a question yet, we'll take a few more and then right there.
Do you know why all planets and stars are shaped like a sphere?
Oh, that's a physics question.
Yeah, so all of the planets and stars are shaped like spheres because they're so big. Eventually, when you have enough mass, all of the gravity is pulling down towards the center, and it's pulling equally in all directions. So if we had a piece that stuck up too far, it would get pulled back down into a sphere.
That actually, one question I was thinking of is, so the kids are always wondering, well, why aren't we flying at the sun if the sun's gravitational pull is so strong? Could you speak to that a little bit? I feel like that's a good physics one for you.
Yes, so it's the same reason the moon doesn't fall to Earth. It's the same reason our spaceships, like the space station that's orbiting Earth, doesn't fall to Earth. And that's they are falling towards us, but they're flying away from us fast enough that so if the Earth is here and you're flying across it, you're getting pulled down as it's rotating. That's not a good visual, I realize. But essentially they're flying fast enough to keep themselves from falling. And the same thing happens with the Earth, that we're moving through space fast enough that we're equally matched with the sun's gravity pulling us in.
Awesome.
Does that make sense?
Yeah, that does. Okay, well, Crosby, we'll have one more question, and then maybe we can finish up with a little advice for budding astronomers. We have a lot of kids in here who are interested in doing something similar. So Crosby's question, and then we'll wrap it up.
This is another physics question. We just learned that like the Earth is traveling at like something like 66,000 miles per hour. How come we don't actually feel it?
We don't feel it because we're moving at the same speed. So the Earth is moving and you're on top of the Earth and moving. It's like when you're in an airplane, you don't really feel like you're moving. You're just sort of sitting there in your seat. or like when you're in your car, I guess you feel it a little bit in your car. The trick is that we're not changing speeds. So we're good at telling when we've changed speeds, when we're speeding up or slowing down. But if you're moving at one speed and can't see anything around you to see things moving past you, you don't really notice that you're moving. Does that make sense?
Yeah.
Why do you think Earth is tilted on its axis?
I don't know. That's a really good question, and something we're still kind of trying to figure out, because we're tilted about 20 degrees on our axis. Some of the planets aren't tilted as much. Some of the planets, I think Uranus is tilted like 90 degrees on its axis. So it's rolling instead of spinning like we are.
What would be your guess on why?
I don't have a good guess. I don't know enough to make a good guess.
Okay, one more, and then we'll finish up right here. Yes, my dear.
When you were in Simpson, did you ever help out at Urban?
Ooh,
I did do a couple reading days at Simpson where I came and read to kids. Yeah.
that's pretty cool. Well, wonderful. Well, is there any advice that you would like to give these budding scientists as they continue on their journey of building their knowledge?
I would say keep asking questions. You guys asked really, really good questions. You asked questions I didn't know sometimes, and that's okay too. So keep asking questions, keep learning. Always be okay to say that you don't know something, because that's an opportunity to find something new.
Wonderful. Well, we are so appreciative of